Problems 1 and 2 on this review say solve using the substitution method. I'm not married to the substitution method. If you find a problem easier to use the elimination method on, you can. Problem 1, it's really set up nicely for the substitution method because the bottom equation is already solved for x. I'm going to solve problems 1 and 2 using the substitution method, but if for any reason you use the elimination method on the test and you avoid the substitution, that's okay. So eventually I will substitute x equal to y plus 1 for the x in the top equation in a better version of the top equation. Because I don't like this version of the top equation. The version of the top equation that's there is loaded up with fractions, and I don't really like to deal with fractions. And when you have a problem that has both an equal sign and fractions, you can clear the fractions. So I'm going to create a better version of the top equation by multiplying through by 20. And when I multiply through by 20, it's going to make some of the numbers bigger, but it's going to get rid of the fractions. So first multiplication by 20, I'm going to cancel the 20 with a 5. It's going to leave me with a 4. And I'm going to multiply this 4 times 4x and get 16x. Second canceling, I'm going to cancel the 20 with the 4 and get a 5. Fraction will be gone. I'll be left with 5 times 1y. I'm going to multiply 5 times 1 and get 5 times y and get y, and have a plus 5y. And to the right of the equal sign, there's no canceling. I just multiply 20 by 5 and get 100. Now I'm going to substitute into the better version of the top equation, which is this. So in for the x, I'm going to put in y plus 1. That's why I call it the substitution method, because I'm substituting from one equation to the other. Hopefully I don't get a fraction for this. So I'm going to clear the parentheses that I just put in by multiplying 6 by y and 6 by 1 and getting 16y plus 16 plus 5y equals 100. I'm going to do two things at once now. I'm going to minus 16 from both sides to get the numbers kind of thrown on the right hand side. And I'm going to add up the 16y and the 5y to get 21y. So on the left side, I'm going to write 21y. 16s are going to cancel. And on the right side, I'm going to write 84 because 100 minus 16 is 84. And now I'm going to divide both sides by 21. And that's going to give me y equal to 4. Every time I'm solving a system of equations, my answers need to be in pairs or triples if there's a z. So I'm going to solve for x to finish up this problem. I'm going to use x equal to y plus 1, which is the easiest way to solve for x, and plug in 4 for y. I'm going to get x equals 4 plus 1. That's going to give me x equal to 5. My answer to problem 1 is going to be x equal to 5, y equal to 4. I can check if I want to, and the checking is optional, but if I wanted to check, I should check in the very original problem my answer 5 and 4. In the top equation, if I wanted to check, I'd have to go 4/5 times 5 plus 1/4 times 4, and that should equal 5. Let me do that first on my calculator. So on my calculator, it's the best place to do checking with fractions. So parentheses 4 divided by 5 times 5 plus parentheses 1 divided by 4 times 4. And when I hit enter, it best say 5 because the right side is already 5. It does, so I know it checks there. So that's checking into the original top equation. Now I'll go to the bottom, x equals y plus 1, and for that x I'll plug 5, and for that y I'll plug 4, and that's also going to give me 5 equal to 5. So I know I'm perfectly checked. Both equations I took the answers separately, plugged them to the x and y into both equations, and I got two true statements. I know for sure my answer is right. Problem 2, just because it says to solve using the substitution method, I'll use it, but it's really set up better for the elimination method. But because it says use the substitution method, I'll just do it. And what I'm going to do to get started on the substitution method, the first step on the substitution method, if it's not already done, is to pick an equation and pick a letter to solve for and solve the equation for that letter. The best first step for substitution method in problem 2 is to pick equation 2, the bottom equation, and solve for x, because the x in that equation doesn't have a coefficient nor a negative sign in front of it. So my first step, if I was going to solve problem 2 using the substitution method, would be exactly this. I couldn't think of a better first step. So I picked the second equation, I solved it for y. That I didn't have to do on the first step because the second equation was already solved for x. I picked the second equation and solved it for x. Now I'm going to substitute into the top equation. Very specifically, I'm going to take this x in the top equation and to change it to y plus 41. I'm surprised to see such a big number. That 41 is not really comforting, but it is what it is. So in the top equation, 3x minus 2y equal to 5, I'm going to change the x to y plus 41. And because that's a binomial, I put it in a parentheses. Now I'm going to clear the parentheses by multiplying 3 times y and 3 times 41. This is going to give me 3y plus 123 minus 2y equals to 5. This is a really odd problem. That 41, I have no idea how it got to be so big. It feels like a typo, but I can deal with it. I'm going to do two things at once again to get this problem solved. I'm going to minus 123 from both sides. And that's going to cancel the 123s on the left side. And on the right side, 5 minus 123 is negative 118. On my left side, the other second thing I was going to do is subtract 3y minus 2y. And that's beautiful, because 3y minus 2y is 1y, and I could just write that as y. That's half of my answer. So I've got the y solved for. Now I'm going to solve for x. All my answers need to be paired up, unless there's 3 letters, and I need triples. And to solve for x, I'm going to use x equals to y plus 41. I'm going to get x equals to negative 118 plus 41. I really don't want to do this wrong, so I'm going to go negative 118 plus 41. I'm going to get x equal to negative 77. So my answer to problem 2 is x equal to negative 77, y equal to negative 118. It's nice to check. In the first problem, when I went to check, it wasn't set up for elimination method, which means it really wasn't set up to check using matrices. Problem 2 is set up so perfectly, I'm going to check it with matrices. So I'm going to check it by taking this and writing it as a matrix, 3, negative 2, 5, 1, negative 1, 41. And I'm going to do R, R, E, F, A, and I hope like heck to get the answers of negative 77 for x and negative 118 for y in the right-hand column of this matrix. That's the quicker way to check. And you could only do that if the x's and the y's are lined up and the numbers are off to the equal sign, and they're all linear equations, meaning there's no exponents on the letters. So second matrix, edit. I'm going to enter a 2 by 3 matrix. I'm doing 3, negative 2, 5, 1, negative 1, 41. Second quit, then second matrix math. Easier to go up than it is down to RREF. And then second matrix, enter, parentheses, enter. I see negative 77 and negative 118. So that's right for the problem that I have written here. I almost feel like maybe that should be a 4 and not a 41. What I did is perfectly correct, and I checked it to be correct. So we'll call it the right problem, but that number really bugs me. But it's correct. Problems 3 and 4 say solve using the elimination method, and I'm going to check using my RREF on my calculator because this is a system of linear equations perfectly set up for that. What I'm going to do on problem 3 is I'm going to eliminate the y's, specifically because the top equation has a positive in front of the y, the bottom equation has a negative in front of the y. The y's need to have opposite signs to eliminate them. The x's have the same signs, so they're a little bit harder to eliminate. And what I'm going to do is I'm going to create a positive 12y in the top equation and a negative 12y in the bottom equation, because when I add those together, the y's will cancel. To create a positive 12y in the top equation, I'm going to multiply everything in the top equation by 4. So I'm going to go 4 times 2x, 4 times 3y, and 4 times 13. There's my 12y in the top equation. To create the minus 12y in the bottom equation, I'm going to multiply everything in the bottom equation by 3. I'm going to go 3 times 5x and pick up a 15x, 3 times minus 4y and get a minus 12y, and 3 times 21 and get a 63. Now I'm going to add the equations together. 8x plus 15x is 23x. Force the y's to cancel. 52 and 63 is 115. And now I'm going to divide both sides by 23. And 115 divided by 23, I think it's 5. But I don't know that. It is. So part of my answer is x equal to 5. The bad thing about the elimination method, it's harder to solve for the second letter. I need to solve for y, and I can pick any letter, any equation in this problem. I like to pick one that has smallish numbers and positive in front of the letters that I'm looking for. So I'm going to use the equation 2x plus 3y equal to 13 to solve for y, but I could have used 5x minus 4y equal to 21. It just has a minus in front of the y that I didn't like. So I'm going to plug in 5 for x into this top equation, and that's going to give me 10 plus 3y equals to 13. Now I'm going to minus 10 from both sides. That's going to give me 3y equals to 3. And then I'm going to divide both sides by 3. And that's going to take me to y equal to 1. I'm going to write my answer as a point. So my answer, x equal to 5, y equal to 1, I write it as a pair or a point with the x first and the y second. To check this, because it's so easy to check, I should check. To check, I'm going to enter the matrix 2, 3, 13, 5, negative 4, 21. I'm going to do RREFA, and I better get 105011 because the answers always wind up in this right-hand column here, and that's x equal to 5, y equal to 1. Super easy to do on my calculator, so I'll do it real quickly. So second matrix, over to edit, type in 2 by 3, and then enter the 2, 3, 13, 5, negative 4, 21. Quit out of it, and then second matrix math. You can go up or down to get to RREF. It's quicker going up. Then second matrix names, enter. Close my parentheses, enter. I see 5 and 1. My answer I know is right. You can only use matrices for systems of linear equations. If there's an x squared or a y cubed, you couldn't use matrices. 4 also wants me to use the elimination method. Let me figure out what the answer is real quickly. So to get my answer, because I'm worried because of the fractions, to get my answer, I'm going to enter the matrix 4 divided by 9, 2 divided by 3, 12, 1, negative 1, 12, whoa, and do R, R, E, F, A. It should give me 1, 0, 0, 1, and then the answers. When I enter this, when I type 4/9, my calculator is going to turn it to a decimal. That's okay. So I'm going to go second matrix, edit, enter, 2 enter, 3 enter. Then I go 4 divided by 9. It'll give me a decimal. I'll live with that. And then 2 divided by 3, not 13. 2 divided by 3 and enter. And then 12 and enter. And then 1, negative 1, and 12. Second quit, second matrix, math, up to RREF, second matrix, enter, close my parentheses, and it gives me 18 and 6. So my answer is going to be x equal to 18, y equal to 6. So eventually, I need to write down my answer of 18 and 6, and on the test, you'll get not so many points for the correct answer. Most of your points are going to be for the correct work. A correct answer with no work is going to get minus everything because you could just press buttons. If I want to use the elimination method, I don't want to use the top equation. I'm going to modify the top equation before I jump into my elimination method because those fractions just aren't really desirable. So I'm going to multiply everything in the top equation by 9. I'll go 9 times 4 9's x plus 9 times 2/3 y equals to 9 times 12. First 9's just cancel completely, and it leaves me with a 4x. Second 9 cancels with a 3 and becomes a 3. Fraction canceled, I'm left with 3 times 2 times y, which is plus 6y. And to the right of the equal sign, 9 times 12 is 108. So now I'm going to take that equation, 4x plus 6y equals 108, and I'm going to emphasize x minus 1y equal to 12, and I'm going to solve these doing the elimination method, and I'm going to drop out the y's. Again, they have opposite signs. I'm going to leave the 6y in the top, and I'm going to create a negative 6y in the bottom so that when I add the equations together, the y's will cancel. To create the negative 6y in the bottom, I multiply the bottom equation by 6. I have to rewrite the top equation, so I'm going to write 4x plus 6y equals 108, and now 6 times x is 6x. 6 times minus y, or 6 times minus 1y is minus 6y, and 6 times 12 is 72. Add these together, 4x plus 6x is 10x. The y's cancel, 108 plus 72 is 180. And now I'm going to divide both sides by 10. And when I do that, I get x equal to 18. Now I need to solve for y. I can pick any equation, and I have a very nice equation. I'd never use that equation to solve for y because it's ugly. This equation to solve for y has a negative in front of the y. That's not so offensive. I think I'll use it. I could use this one as well, but the numbers are big. Let me use this one to solve for y. So as I go to solve for y, I'm going to use this equation. I'm going to emphasize it's x minus 1y equals to 12. I'm going to plug in 18 for x. It's going to give me 18 minus 1y equal to 12. I'm going to minus 18 from both sides. That's going to give me minus 1y equals minus 6. And now I'm going to divide both sides by a negative 1. On the left side, the two negatives cancel out to be a positive 1y. And on the right side, the two negatives cancel out and I get a positive 6. So there's my x equal 18, y equal to 6 that I knew I was going to get ahead of time. There's going to be one problem like number 5 and 6 on the test where they give you 3 equations and 3 unknowns. And it would help me a lot when I grade if you follow my instructions, but if you don't, I'll live with it. I'm going to get my answer ahead of time. To get my answer, I'm going to enter a 3 by 4 matrix, And the 3 by 4 matrix I'm going to enter is going to be 2, 4, negative 5, negative 5, negative 1, 1, 2, 5, 1, negative 3, 3, 4. And when I enter this, it's going to come back with 1, 0, 0, then a number, 0, 1, 0, and then a number, 0, 0, 1, and then a number. The numbers in this far right-hand column are going to be my solutions in the order x, y, and z. So entering the matrix, so important to enter these right. So second matrix, edit, 3, enter, 4, enter, and then 2, 4, negative 5, negative 5, negative 1, 1, 2, 5, 1, negative 3, 3, 4. Second, quit. Second, matrix math. Second, matrix enter, enter, error syntax. Oops, forgot. Second, matrix math. I must not hit the REF. Second, matrix enter, enter. I don't like this. Math, enter, enter. Let me just write these numbers down temporarily because I may have entered something wrong on my calculator. I'm surprised to see those as the answer. So let me double check this. 2, 4, negative 5, negative 5, negative 1, 1, 2, 5, 1, negative 3, 3, 4. I'm going to re-enter the whole entire matrix because sometimes when you make a mistake you can't see it. So I'm just going to retype every number in. And I'll live with an ugly fraction answer, but that's not really what I generally expect for answers. So second, quit. Second, matrix math, RREF. Second, matrix names, enter. It is what it is. So the answers to this is going to be x is 11 over 14, y is 17 over 14, z is 16 over 7. So this right here is my answer. I would be really surprised if on a test I gave you a problem that had fraction answers, but this is good character building. So my suggestion to start off was to pair the middle equation with the other two and drop out the x's. So to finish this problem up by hand, I'm going to have to do the elimination method 3 times. So step 1, I'm going to pair the middle equation, negative x plus y plus 2z equal to 5, with the top equation, 2x plus 4y minus 5z equals to negative 5. And I'm going to pair the middle equation, negative x plus y plus 2z equal to 5, with the bottom equation, x minus 3y plus 3z equal to 4. I'm going to eliminate the x's. This is going to be easy. This is going to take a little more work. To eliminate the x's in this one, I'm going to make the top have a negative 2x. It already has a negative 1x. So I'm going to multiply everything in the top equation by 2. Get 2 times negative 1x is negative 2x, plus 2 times y is plus 2y, plus 2 times 2z is plus 4z, equals 2 times 5, which is 10. And then I'm going to go 2x plus 4y minus 5z equals negative 5. Add these together, I'm going to get 6y minus 1z equals to positive 5. These I can drop out the x's by just adding them together because the x's already have opposites in front of them. So I'm going to add those. The x's will cancel. 1y minus 3y is minus 2y. 2z plus 3z is 5z. 5 plus 4 is 9. Now I'm going to stack these on top of each other and do my elimination method for the third and final time. So the first step, I do the elimination method twice. The second step, I do the elimination one more time. And that's going to give me answers for 2 of the 3 letters. So 6y minus 1z equal to 5, and minus 2y plus 5z equal to 9. That's the results of my first step. I stack them on top of each other eliminate, solve by the elimination. I'm going to solve this by the elimination by multiplying by 3 to clear the y's. So I'm going to leave the top 6y minus 1z equal to 5, and the bottom is going to be minus 6y plus 15z equals to 27, because 3 times 9 was 27. Add these up, I'm going to get 14z equals 27 plus 5 is 32. And then I'm going to divide both sides by 14. The left side I get z. The right side, 32 divided by 2 is 16. 14 divided by 2 is 7. It's part of my correct answer. Now I need to solve for y. To solve for y, I can pick any equation that has a y, preferably one that just has a y and a z, preferably one that has a positive in front of the y. I'm going to use this one. I'm going to use 6y, so I'm solving for y, 6y minus 1z equal to 5, and now I'm going to plug in 16 over 7 for z. So I'm going to get 6y minus 1 times 16 over 7 equals to 5. This is going to give me 6y minus 16 over 7 equals to 5, and now I'm not going to cheat, but I'm going to use my calculator. I'm going to add 16 over 7 to both sides. On the left side, the 16 over 7s are going to cancel. I'm going to be left with a 6y. And for the right side, I'm going to go 5 plus 16 divided by 7, and then math, enter, enter. That's 51 over 7. Now I need to divide both sides by 6, or I can multiply by 1/6. But I'm going to divide by 6, and I'm going to go 51 divided by 7 divided by 6, and then math, enter, enter. This gives me y equals to 17 over 14. Peek back at that first page and where my answer was, and there's the 17 over 14. So I have my horrible y, my horrible z. I need to get my horrible x. To solve for x, I can use any equation that has an x. I prefer one that has a positive x, so I'm going to use that equation to solve for x. And I'm going to use those two answers of 17 over 14 and 16 over 7. So as I go through to finish up problem 5, my last step is to solve for x. I can use any equation with an x to solve for x, but I might as well use the one with the nicest x. And I'm going to exploit the heck out of my calculator because I don't want to do fractions by hand. I'm just going to mess up. So first step, I'm going to go 3 times 17 over 14, or minus 3 times 17 over 14. So minus 3 times 17 divided by 14, 14 equals, math, enter, enter. That's 50 minus 51 over 14. So this is going to be x minus 51 over 14, and then plus 3 times 16 over 7. 3 times 16 divided by 7. That's going to be plus 48 over 7 equals to 4. And now I'm going to do minus 51 over 14 plus 48 over 7. Doing minus 51 divided by 14 plus 48 divided by 7. Math, enter, enter. This gives me plus 45 over 14 equals to 4. So I'm just exploiting my calculator's ability to do fractions because I don't want to do these fractions by hand and make a mistake. Last step to solve for x, minus 45 over 14 on both sides. On the left side, I just have to cancel the 45 over 14s. On the right side, it's 4 minus 45 divided by 14. Math, enter, enter. And I get x as 11 over 14, which is exactly what I have. So all my algebra, that I need to show it all. I need to see the algebra to give the z, the algebra to get the y, the algebra to get the x. The answer is far less important than the work for this particular problem. So there's the answer. I knew it even before I did any work. So on a test, a plain answer isn't going to get you a lot. All right, so 6, another monster problem. There's only going to be one of these on the test. Let me do my checking, or establishing my answer. I'm going to eventually do RREFA for a 3x4 matrix that has 2, 1, -5, and 3 from the top row, -3, 2, 5, and 0 from the middle row, 1, -1, 1, and 4 for the bottom row. If you get a fraction on the test, you've probably messed up. It's very, very rare that I put a problem that has 3 equations and 3 unknowns that has a fraction answer on the test. It's hard. It's easy enough to make a mistake when the answers aren't fractions. So if you get a fraction, just like I did when I did it on my calculator, I was like, man, I got a fraction. That doesn't feel right. Again, I'm so disappointed in myself. So it looks to me like the answer is x equals 81 over 17, y equals to 44 over 17, z equals to 31 over 17. I'm really not happy with this. Let me double check by redoing this whole problem. So 2, 1, -5, 3, -3, 2, 5, 0, 1, -1, 1, 4, second quit, second matrix math, RREF, second matrix enter, enter, it's just what it is. Sorry about that. Well, the test will be easier. All right, let me follow my help instructions. Pair the bottom of the equation with the other two and drop out the y's. So first step, I'm going to take the bottom equation, x minus y plus z equal to 4. I'll pair it with the top equation, 2x plus y minus 5z equals to 3. And I'll pair the bottom equation, x minus y plus z equal to 4, with the middle equation, minus 3x plus 2y plus 5z equal to 0. I write this on the test, what I want you to do to start, because it makes my grading easier. So I'm going to drop out the y's. The first equations, the y's will drop right out just by adding them. I'm going to add 1x plus 2x and get 3x. The y's will cancel. 1z minus 5z is minus 4z, and 4 plus 3 is 7. To drop out the y's in the second pairing, I need to make the top have a minus 2y by multiplying through by 2. So I'm going to rewrite the top as 2x minus 2y plus 2z equals to 8. That's multiplying every line in the top equation by 2, and leaving the bottom minus 3x plus 2y plus 5z equals to 0. When I add these, I get negative 1x, y's cancel, plus 7z equals to 8. Now I'm going to take the two different answers, or two different equations I got, and stack them on top of each other and solve those. So I'm going to put 3x minus 4z equal to 7 on top of negative 1x plus 7z equal to 8. This is my third go at the elimination method. I'm going to eliminate the x's by multiplying by 3. When I do that, I can leave the top 3x minus 4z equal to 7, make the bottom minus 3x plus 21z equals to 24. When I add these together, the x's cancel. I get 17z equals to 31. I'm going to divide both sides by 17, and I get z equal to 31 over 17. That's very good, because I know that that's right. Now I'm going to solve for x, because I have an easy stab at solving for x. And I could use any one of these equations that I've just been working with to solve for x. I don't know which one is better. They both have their issues. This one has a negative in front of the x. This one has a 3 in front of the x. They both will work. I'd rather have a 3 than a negative. So I'm going to use the equation 3x minus 4z equal to 7, and I'm going to plug in 31 over 17 for z. When you multiply this, you just multiply the 4 and the 31. This is going to give me 3x minus, let me just do this, 4 times 31 divided by 17. It's going to be minus 124 over 17 equal to 7. And now I'm going to add 124 over 17 to both sides. And I'm exploiting the heck out of my calculator, so the fractions are just a nuisance because I have to press buttons. On this left side, I cancel out the ugly fraction. On the right side, I introduce an ugly fraction by going 7 plus 124 divided by 17. Math, enter, enter. This gives me 246 over 17. And now I need to divide both sides by 3. On the left side, when I divide by 3, I get my x. On my right side, I better get 81 over 17. So on the right side, clear all this out. 246 divided by 17 in a parentheses, divided by 3 equals math, enter, enter, and I get 82 over 17. Really? That's troubling, to say the least. Because the answer is supposed to be 81 over 17. Now the question is, did I make a mistake or did I write something wrong down at the beginning? Let me see if I wrote something down wrong at the beginning. First of all, checking my matrix. 2, 1, negative 5, negative 3, 2, 5, 1, negative 1. 4. That looks okay. Second matrix, math, RREF, second matrix. And the answer is supposed to be 81 over 17. Uggle, uggle, uggle. Not excited about that. Did I make a mistake here? Who knows? So let me go back. I feel like this is okay. So I got the right answer for z. So I should be able to use 3x minus 4z equal to 7. I plugged in 31 over 17. I did minus 4 times 31 divided by 17. Math, enter, enter, and got 124 over 17, which I added to both sides. So I go 7 plus 124 divided by 17. Math, enter, enter. I get 243 over 17. I don't know what I did wrong right there, but when I did this adding on my calculator, just made a mistake. So this is supposed to be 243 over 17 divided by 3. Now let me do that to clean it up. So 243 divided by 17 divided by 3. Math, enter, enter, and I get 81 over 17. So when I make a mistake, sometimes I refilm the video so you don't have to see my mistake, but it's going to happen to you on the test. Some of you will make a mistake. You'll know the answer ahead of time. You'll make a mistake, and the best thing to do is start searching out your mistake. So the first thing I did is, well, maybe I did a calculator error at the beginning. Check that. It wasn't a calculator at the beginning. And then I knew I had the z right, so I just started looking at my math that I was solving for x. Finally, it took me a while, but I found that mistake, fixed it, and now I can move on and solve for y. I certainly wouldn't go on to solve for y if I didn't have the other two answers right. I need any equation with a y. I like this top equation because it has a nice version of the y. So I'm going to use 2x plus y minus 5z equal to 3. And in for x, I'm going to plug 81 over 17. And in for z, I'm going to plug 31 over 17. So I'm going to go 2 times 81 over 17 plus y minus 5 times 31 over 17 equals to 3. Let me clean up that right side. First, I'm going to go 2 times 81 divided by 17 and get 162 over 17 plus y, and then minus 5 times 31 over 17. It's going to be minus 155 over 17 equal to 3. Now I'm going to combine those by going 162 over 17 minus 155 over 17. And math, entering. This is going to give me y plus 7 over 17 equals to 3 Then I'm going to minus 7 over 17 from both sides. All calculator work. I don't want to do this by hand. So on the right side, I need to go 3 minus 7 divided by 17. Math, enter, enter. On the left side, I cancel out and be left with the y's. On the right side, I have 44 over 17. That better be x equal to 81 over 17, y equal to 44 over 17, z equal to 31 over 17. And that's exactly what I have. X equals 81 over 17, y equals to 44 over 17, z equal to 31 over 17. No, my answer is right. Really not happy that I gave you two fractions, but it's, if you can do the fractions, you can do the non-fractions a lot easier. All right. 7 and 8 want me to use matrices. I deleted. There's no 9 and 10 anymore. 9 and 10 had x, y's, and z's and wanted me to solve with matrices. And that takes so long to do, you can't really do it on an hour and 15-minute test and ask much else. So I'm going to solve these using matrices, and I'm going to have a beginning matrix, a second matrix, and a final matrix. Eventually I'll check on my calculator. I could do it now, but I won't. My first matrix is going to be 1, 2, 10, 2, negative 3, negative 1. On my first step, I'm going to eliminate the x's and create a new bottom row. So if your work gets sloppy here, you're going to lose some points for not following the practice that you need to do to solve these in case you need to do matrices in a higher class. So how am I going to eliminate the x's? Well, the x's are here. I'm going to make that x have a negative 2 in front of it by multiplying everything in the top row by 2, and that's going to, by negative 2, and that's going to make the x's cancelable. So I'm going to multiply negative 2 times 1, negative 2 times 2, negative 2 times 10, and stack that on top of 2, negative 3, negative 1. This is potentially my bottom row unless there's a number I can divide out. When I add these here, I get 0, negative 7, and negative 21. Before I create my bottom row, all of these numbers are divisible by negative 7, so I'm going to divide them by negative 7. And this is going to be the bottom row in my second matrix. It's going to be 0, positive 1, and positive 3. So this is going to be the bottom row in my second matrix. We're going to have three matrices. The first matrix, you just pull off the coefficients from the original problem. Easy enough. The second matrix, you change the bottom row, but not the top row. So the top row in my second matrix stays the same at 1, 2, and 10. The second matrix gets a new bottom row, and the new bottom row is 0, 1, and 3. So on the first step, I eliminate the x's and created a new bottom row. On the second step, I'm going to eliminate the y's and create a new top row. And that's going to be it. That's going to have my answer staring at me in the right-hand column. I'm going to make this 1 into a negative 2 so that the numbers will cancel. I'm going to multiply everything in the bottom row by 2 here in a second. I'm going to leave the top row 1, 2, and 10, and I'm going to go 2 times 0 is 0, negative 2 times 0 is 0, negative 2 times 1 is negative 2, negative 2 times 3 is negative 6. I'm going to add these together and get 1, 0, and positive 4. That's going to be my top row. There's no number that I can divide there. So this is going to be my third and final matrix. Each one of these problems that has an x and a y that you're solving with matrices, you're going to get an initial matrix that comes for free, a second matrix with a new bottom row with the x's dropped out, a third matrix with a new top row with the y's dropped out, and now I should be able to read my answer. My answer should be x equal to 4, y equal to 3. Let me check that real quickly by entering that matrix on my calculator and make sure I get that same matrix. So on my calculator, the checking, second matrix, edit, 2 enter, 3 enter, then 1, 2, 10, 2, -3, -1. Second quit, second matrix, math, RREF, second matrix, enter. Perfect, my answer is right. Do the same thing for problem 8. I'm going to create a matrix from the system of equations. I'll have a first matrix. Then I'm going to eliminate the x's, create a new bottom row, make my second matrix. Then eliminate the y's, create a new top row, have my third and final matrix that will match up with my calculator. So, problem 8, first matrix. So this says to solve using matrices, otherwise I wouldn't solve using matrices. So 3, -2, 11. 1, -7, -10. So step 1 is I need to eliminate the x's and create a new bottom row. I'm going to eliminate the x's by leaving the top 3 and making the bottom have a -3. I'm going to multiply everything in the bottom equation by -3 to get that to happen. I'm going to leave the top at 3, -2, and 11. In the bottom, I'm going to go -3 times 1 is -3. -3 times -7 is positive 21. -3 times -10 is positive 30. Add together and get 0, 19, and 41. This is troubling to say the least. 3, -2, 11, 1, -7, -10, -3, -2, 11, 20. Now, I don't think this divides. I don't think 41 divided by 19 doesn't do me any good, so this is going to have a nasty fraction answer. Yeah, I'm going to leave that, and that's going to be my second matrix bottom row. So in my second matrix, my top row is going to stay 3, -2, 11. My bottom row is going to be 0, 19, and 41. Now I need to eliminate the y's and create a new top row. I'm going to do that by making this a -38 and that a positive 38. I'm going to multiply the top row by 19, the bottom row by 2, and that's going to force the numbers in the y column to cancel out. So I'm going to go 19 times 3, which is 57. 19 times -2 is -38. And I'm doing it off screen. I don't know what 19 times 11 is. I'm just pressing it on my calculator. Is 209. Bottom row, 2 times 0 is 0. 2 times 19 is 38. 2 times 41 is 82. Add these together, I get 57, 0, and again I can't do 209 plus 82 in my head, I guess I could, is 291. Now I'm going to see if I can divide 291 divided by 57. So I'm going to go 291 divided by 57, ugly decimal, so I'm going to leave that as my new bottom row, and I'm going to get my next matrix, my second matrix, which is kind of my final matrix, but not so perfect for my final matrix. My third matrix that I'm going to improve upon to match up with my calculator, because my calculator is going to have the answer staring at me, and I'll get those answers here in a second. My third matrix, the top row is going to be 57, 0, and 291, and the bottom row is going to stay 0, 19, and 41. So the algebra that I did was to create a new top row. Unfortunately, my calculator, there's no way my calculator is going to give me that for an answer. So what I'm going to need to do is divide everything in the top row by 57 to make the answer appear in the right-hand column, and everything in the bottom row by 19 to make the answer appear in the right-hand column. So this will actually be my final matrix. I just didn't want to introduce those fractions any earlier than I had to. So my final matrix, 57 divided by 57 is 1. 0 divided by 57 is 0. And then 291 divided by 57 is a decimal. Let me see what it is as a fraction. It's 97 over 19. So I'm going to write 97 over 19 here. Bottom row, 0 over 19 is 0. 19 over 19 is 1. And 41 divided by 19 is a nasty decimal. Let me reduce that fraction. It's still 41 over 19. So my answer, I can only read off my answer when there's ones in the x and the y position in the first two rows. My answer is going to be x equal to 97 over 19, y equal to 41 over 19. I'm going to check, because it's so easy to check. To check to see that this answer is right, I'm going to take my initial matrix before I did any work that I just stole from that and RREFA it. Better get that. So second matrix, enter this 2 by 3 matrix of 3, negative 2, 11, 1, negative 7, negative 10. Second quit, second matrix math, RREF, second matrix A. Got to math, enter, enter, and I see 97 over 19, 41 over 19. I know my answer is right, so I feel good about that. This might be the right time to make a part 2, because we still have a chunk of problems left, and we're about 60 minutes into this video, so I'm going to pause it and do a part 2.